Hello, myself Shri Vallabh Phadke, and I'm here to give the demo for the science lecture. So in this, I've chosen the topic of gravitation. So I'll write the topic name here, that is in gravitation. And in gravitation, today I'll be explaining the Kepler laws. So in this Kepler's laws, we have basically three laws, that is the Kepler's first law, second law, and the third law. So all of these three are in the chapter of gravitation, and these are very important for your 10th standard as well as for your college or 11th, 12th standard. So let's jump in. The first is the Kepler's first law. So what is the first law state? So the first law states that, for this I'll draw a diagram here. So for example, this is an orbit. So let's suppose this is a sun here, and we have a planet, the orbit of a planet, and the first law states that the orbit of any planet is of the shape elliptical, or you could say ellipse. Now, if you want to see what is an ellipse, you can basically take a cone. For example, you know the cone, you have those ice cream cones. You can take those ice cream cones and you can cut them at an angle. So if I cut this ice cream cone at an angle like this, what I get is basically a shape like this. I will get a shape like this. So this is known as an ellipse or an elliptical shape. So what the first law states that the orbits of any planets in the universe, you can take any planet, that orbit will be of the elliptical shape. It won't be a perfect round. It will be like this. And that's what the first law states that. So the orbit of a planet is an ellipse with the sun at one of its foci. So the sun will be at one of its focus or at the point of interest. So you'll have something at the focus and the planet will be revolving around it. So that is the first law. Now let's move on to the second law. Now the second law states that, again I'll draw an ellipse like this. I will draw a sun in between. Now here I'll join some lines, okay? I'll join, say, like this. I'll join here. I'll join here. I will join like this. I'll name this. I'll name the sun, I'll say S. So A, B, C, D, E, and F. So here what it states that, suppose the planet now is at the position A. Now this planet is going from A to B, and it goes from A to B. Now we have this area, okay? So I'll call this ABS. So the area of ABS. So I'll do like this here. So this area which you can see, so it will have certain value, okay? We'll just take an example. So let's take an example that the area of this is suppose 10, okay? It's not 10, but let's assume that it is 10. Now if that planet goes to this position, okay, to C position, from C to D, now again I calculate the area of this path, okay, this whole area, this one. So here I am calculating the area of C, D, and S. Now if you calculate it, the value will be the same as the first one, that is the 10. So this area is assumed, I'm saying it again, so this will be the same area. Now again, if you move on to the third one, if the planet is at E and moves to F, so we'll have this area, say the area of EFS. Again, if you calculate it, the area will be the same 10 only. So what it means that the line joining the planet, yes, these are the lines joining the planet, will sweep equal areas. That's why the areas will be equal. So if you look at this diagram, you might say that, okay, the area of CDS will be more and the area of maybe EFS will be less, but it's not like that. So you can take any 2 points on the orbit, you can join them to the foci, and you can calculate the area. The area will be the same only. It won't change. And that's what the second law states that. So the line joining the planet and the sun sweeps equal areas in equal intervals of time. That is the second law. And let's move on to the third law now. So for the third law, again, I'll draw this. This is the elliptical orbit which you have to remember. This is sun at the foci. Yes, there's a planet something. Let's say Earth it is. So what it states that, let us assume here first that let the period of revolution for that planet, let that be say t. That is the time for its revolution. And let's say the time for revolution. And let's say r is equal to the distance from the center or from the foci. Now what the third law states that the square of the period of revolution, that is the t square, is directly proportional to the cube. Okay, so to the cube of the mean distance of a planet from the sun. That's what the third law states. So if, as they are directly proportional, if the time for revolution increases, the distance will increase. If the distance increases, the time of revolution will increase, and vice versa. If the distance decreases, obviously the time of revolution will decrease. So for this, it is written like this. So to remove the direct proportional sign, we have to put a constant. So the t square upon r cube is equal to k. And this k, this constant k, is known as the Kepler's constant. Hence, these are the three laws for which will be beneficial for your study of gravitation. The first law states that the orbits will be elliptical. Second is that the planets sweep equal areas in equal intervals of time. And the third is that the t square is directly proportional to the r cube, where t square is the period of revolution and r is the distance. And they have given a constant here, that is k, that is the Kepler's constant. So this is my video. Thank you.